Hello everyone. Welcome to the orientation session on Digital Accessibility Design and Testing. In this session, we plan to cover the below topics: Introduction to Digital Accessibility, Introduction to WCAG Guidelines. Then it has coverage on 10 key accessibility success criteria and 10 key problems observed by accessibility auditors. We will cover WCAG guidelines in detail. From accessibility implementation perspective, you will have takeaway on engineering practices for accessibility compliance. Towards the end, we will cover developer due diligence for accessibility. As an annex tour, you get Accessibility Developer's Guide. Digital accessibility refers to designing and developing digital products, such as websites, applications, software, and electronic documents, in a way that makes them usable and accessible to people with disabilities. Before starting with digital accessibility in detail, let's first understand the term of accessibility. Accessibility is the practice of making information, activities, and/or environments sensible, meaningful, and usable for as many people as possible. Let's understand the three key objects of this definition here. Making information and content accessible, in any form. Covers basic things like title, heading, structure of a document to its formatting and layout, to the use of visual media and graphical and typographical elements. Web content is the most important aspect here. Accessibility in context of architectural design. Buildings having accessible entrance, railings, ramps, self-operating doors, lifts or elevators, signs, lighting, even the width and height of steps of a staircase all represent accessible design elements. Accessibility in context of activities we perform. Using computers, websites, telephone and TV systems. Using wheelchair as a means of mobility. Using IDE for design and development of code. It is important to understand that accessibility is about accepting and respecting the solutions and technologies that enable alternate means of access, and then not constructing obstacles to their use. What is digital accessibility? Digital accessibility is the ability of a website, mobile applications, documents, and video, to be easily navigated and understood by a wide range of users. Digital accessibility is important because it enables people with disabilities to access and benefit from digital content on equal terms with others users who have temporary or permanent visual, auditory, motor or cognitive disabilities. It is important to mention here that accessibility is for everyone and we all are benefited with accessibility in different ways. An accessibility user is anyone whose access to information, activities, and/or environments are impeded by a temporary, recurring, or permanent condition, including but not limited to cognitive, physical mobility, auditory, verbal, or ocular disabilities. Age, language, culture, education, economic position, technological aptitude and access. Everyone, either currently, in the past, or at some future point, will belong to one or more accessibility communities. So, let's understand further on digital accessibility. Firstly, it involves making the digital mediums accessible benefits individuals, businesses, and society. Every user deserves a first-rate digital experience on the web. Someone with a disability must be able to experience web-based services, content and other digital products with the same successful outcome as those without disabilities. Digital accessibility is a feature that allows as many people as possible, among others people with various disabilities, to view the content of websites and applications as easily as possible. Here are some examples. Individuals. Digital accessibility benefits individuals with disabilities. It allows them to participate in online activities, such as shopping, socializing, and learning. Businesses. Digital accessibility benefits businesses by increasing their customer base. By making digital products. Society. Digital accessibility benefits society as a whole by promoting inclusivity and equality. The second thing to highlight here is that the power of the digital accessibility, say with web, is in its universality. Access by everyone regardless of disability is an essential aspect. Thanks to digital accessibility, a bigger number of people can read the same information at different locations and will not have difficulties understanding it. Digital accessibility enables a bigger number of people to read the lot of information at different locations. Now, what are barriers in digital accessibility? Here we will learn about the most common barriers in digital accessibility. Factors in a person's environment that, through their absence or presence, limit functioning and create disability. This also includes the negative attitude of people towards disability. It's important to recognize the diverse abilities and assistive technologies people bring to bear on the web. People with low vision often use magnification software. People who are blind may use assistive technology such as a screen reader like JAWS to read web content aloud. Those living with disabilities such as amyotrophic lateral sclerosis, ALS, may use eye tracker software and never use a mouse. And many other users, who you might assume have no disability at all, benefit from alt text, keyboard-only navigation and clear link text. Two other barriers faced on the web are often lack of high contrast mode, lack of voice recognition software. Barriers found in electronic documents and multimedia. Taking example of inaccessible multimedia, i.e. multimedia content, such as videos or audio recordings, without captions, transcripts, or audio descriptions can exclude individuals with hearing impairments or visual impairments from accessing the information being conveyed. Another example is inaccessible forms and input fields, i.e. forms and input fields that are not properly labeled or structured can be difficult for individuals using assistive technologies to complete. Clear labels and logical tab order are crucial for users who rely on keyboard navigation or screen readers. What is the current state of digital accessibility? From various surveys, it's found that 15% of world population lives with some form of disability. Within US itself, 1 in 5 adults has a disability and 8% of males have some degree of color blindness. According to WebAIM Million Report, 1 million home pages for accessibility issues, it's found that 98.1% home pages with at least one WCAG 2.0 failure. 60.9% average number of errors per home page. The causes of the most common accessibility failures, percent of home pages. Low contrast test 86.3%. Missing image alt text 66%. Empty links 59.9%. Missing form input labels 53.8%. Empty buttons 28.7%. Missing document language 28%. Do you know how much of the population is affected by inaccessibility? 1 billion people in worldwide have disabilities. People with disabilities are underserved by today's digital products, from both a civil rights and a business perspective. So, what's required is that they should be able to enjoy the same access to information as those without disabilities. Technologies are available to reduce or remove the barriers to their digital access. To everyone, regardless of age, physical or mental capabilities, can use the internet and have good web experience. Good accessibility strategy also has business benefits and it's a component of design and development. Here we will get to know about the common disabilities in digital space. Below here are the commonly recognized disabilities that affects usability of web and the overall digital experience. 1. Visual impairment. People who are blind or low vision. They will need alternative text descriptions for meaningful images and use the keyboard and not a mouse to interact with interactive elements, such as blindness, low vision, and color blindness. 2. Hearing impairment. People who are deaf or hard of hearing. They will need captioning for video presentations and visual indicators in place of audio cues, such as deafness and hearing loss. 3. Motor impairment. People with mobility-related disabilities. They may need alternative keyboards, eye control or some other adaptive hardware to help them type and navigate on their devices. 4. Cognitive impairment. People with slow learning or cognitive disabilities. They may need an uncluttered screen, consistent navigation, and the use of plain language would be useful for people with different learning disabilities/impairments. More specifically, learning disabilities includes conditions such as dyslexia, which can affect an individual's ability to read, write, or perform mathematical calculations. Common kinds of disabilities covers wide range of disabilities like permanent disabilities, which means an injury or illness or inborn state that results in permanent impairment of routine activities. Examples include older people who is loss of limb, sight, hearing, speech, spinal cord injuries and muscular dystrophy. 2. Temporary disabilities and illnesses or injuries that temporarily prohibit you from participating in daily routine activities, broken bones, recovery from surgery. Examples include people with a broken arm or lost glasses, broken bones, post-surgical recovery. 3. Situational disabilities that are based on a specific set of circumstances. This also includes environments that inhibit the senses. Examples include people in bright sunlight or in an environment where they may have an allergic or sensitivity reaction. Now let's understand the 5 areas of accessibility. The term access or accessibility encompasses 5 different areas. Number 1. Architectural accessibility. It involves creating physical spaces that are functional, safe, and inclusive for everyone, regardless of their abilities. This accessibility refers to the built environment and the means of getting to and from that built environment, whether it is from a parking lot, a bus stop, or the street. Number 2. Programmatic accessibility. Separate and apart from architectural access issues, a program's eligibility requirements, policies, or operating procedures may be causing additional programmatic barriers to full and meaningful access. Programmatic accessibility focuses on the underlying code and markup language used to create web pages, software applications, and other digital content. Number 3. Technology. Technology has become an extremely valuable way to increase inclusion for people with a range of disabilities. Augmentative communication devices, wheelchairs, and screen readers which speak what is on the computer screen are all examples of personal technology used to increase accessibility and inclusion. It can be as simple as a rubber pen grip. Accessibility can be built into the technology that everyone uses. Computers, websites, telephone systems, and televisions all are increasingly accessible to and usable by people with a range of disabilities, including visual, hearing, mobility, and cognitive disabilities. Number 4. Communication accessibility. For persons with hearing, speech, cognitive, or learning disabilities, they may need communication access. Communication access means providing the technology or services necessary to facilitate equivalent communication. In wider terms, communication accessibility refers to making communication more accessible to people with disabilities, including those who are deaf, hard of hearing, blind and visually impaired. Number 5. Alternate formats accessibility. For people with visual impairments, written material needs to be provided in alternate formats. There is a wide range of alternate formats, including Braille, text file, large print, and audio tape. Alternate formats should be provided at the same time that written information is provided. Accessibility is built in fundamentally. By building accessibility into a product from the start, developers can ensure that all users have equal access to information and functionality. This ensures that the software must work in the following situations. Works with a screen reader. Use screen reader to see the page, i.e. NVDA, Windows, Apple VoiceOver, iOS, Chromevox, Chrome extension. Works without hearing. Use of text-to-speech tools and platforms. Under no speech. Works without speech as the only input. Use of chat and similar communication platforms. Under no mouse. Works with keyboard alone. Use keyboard to navigate and tab through interface. Under No Color, works with default colors on page. Disable colors to check contrast and meaning, i.e. WCAG Color Contrast Checker, Chrome extension. The next things to understand here is that compliance to International Web Accessibility Guideline WCAG and ARIA. Make your web content usable by more people in any situation. Follow WCAG and ARIA best practices. Target on WCAG 2.1 AA. Accessibility is about compliance. Accessibility is a civil right and a matter of compliance. This compliance with accessibility guidelines and standards is important to ensure that digital products and services are accessible to everyone. Compliance refers the rules, regulations, or laws of accessibility. Overall, compliance requires us to adhere to established accessibility standards, such as the Web Content Accessibility Guidelines, WCAG, or platform-specific accessibility guidelines. These standards outline best practices and criteria for creating accessible digital content, including websites, applications, and games. Compliance helps ensure that your product meets a set of recognized accessibility criteria. Every country has a different law and compliances around accessibility. A brief list of country-specific accessibility laws and regulations includes the United States of America ADA and Section 508, European Union and 301 549 and European Accessibility Act, Canada ACA, AODA, AMA, and Nova Scotia Accessibility Act, the United Kingdom Equality Act of 2010, Israel Equal Rights for People with Disabilities Act of 2013, Japan JISX 8341-3, Germany Equal Opportunity Act and BITV 2.0, Australia Disability Discrimination Act of 1992, Italy Stanca Act, India RPWD 2016 and Guidelines for Indian Government Websites, France Law and Decree 2005-102 Article 47, Brazil L 10.098. 2. The common compliance standards internationally, as Web Accessibility Guidelines are Web Content Accessibility Guidelines WCAG and ISO/IEC 40500. WCAG. WCAG is developed by the World Wide Web Consortium, W3C, an international community that develops web standards. It provides guidelines and success criteria for making web content more accessible to people with disabilities, including visual, auditory, physical, speech, cognitive, and neurological disabilities. ISO/IEC 40500, ISO/IEC 40500, also known as the International Standard for Web Accessibility, is a technical standard that defines requirements and recommendations for web accessibility. Use of assistive technologies, ET. So, first we will talk about what is assistive technologies, ET. Assistive technologies are tools, devices, software, or hardware that are designed to help people with disabilities or impairments to overcome challenges and accomplish tasks they might not otherwise be able to perform. Assistive technologies can be used to address a wide range of disabilities, including visual, auditory, physical, and cognitive impairments. The goal of assistive technologies is to empower people with disabilities to participate fully in society and achieve greater independence and quality of life. Let's see how assistive technologies, ET, can be helpful to solve accessibility challenges. People with disabilities make use of ET to perform day-to-day activities. They can actively participate in society and lead an independent life. There is a wide variety of ET, using which people with disabilities interacts with digital interfaces. Let's discuss this in more details as how assistive technologies can be helpful in solving accessibility challenges. Screen readers. Screen readers are software applications that read aloud the content of a screen, making it accessible to individuals with visual impairments. They convert text and other visual elements into synthesized speech or braille output. Screen readers enable blind or visually impaired users to access websites, applications, documents, and other digital content. Screen magnifiers. Screen magnifiers help individuals with low vision by enlarging and enhancing the display content. They allow users to zoom in on specific areas of the screen, adjust color contrast, and customize display settings to improve readability and visibility. Braille displays. Braille displays are tactile devices that convert digital content into Braille characters, allowing individuals with visual impairments to read through touch. They provide access to text, graphics, and other visual elements by translating them into Braille output. Alternative input devices. Assistive technologies include alternative input devices like specialized keyboards, switches, or mouth sticks that enable individuals with motor disabilities to interact with digital devices. These devices allow users to input commands, navigate interfaces, and perform actions using their preferred method of control. Voice recognition software. Voice recognition software, also known as speech recognition, enables users to control digital devices and input text using their voice. This technology is particularly helpful for individuals with mobility impairments or those who have difficulty using traditional keyboards or pointing devices. Captions and transcripts. Captions and transcripts provide textual representations of audio content, making it accessible to individuals with hearing impairments or those who may prefer reading the content. Captions are essential for videos, presentations, and multimedia content, ensuring that the auditory information is accessible to all users. Assistive listening devices. Assistive listening devices, such as hearing aids or loop systems, amplify and clarify sound for individuals with hearing impairments. They help improve audio accessibility by reducing background noise, enhancing speech clarity, and increasing the volume of sound. Cognitive assistive technologies. Cognitive assistive technologies support individuals with cognitive disabilities by providing tools for organization, memory aids, and task management. These technologies assist with planning, reminders, time management, and other cognitive processes to help individuals navigate and understand digital content effectively. Here we will learn about the different approaches to ensure accessible design. Accessible design is the strategic process of creating products, environments, and systems that are usable by individuals with disabilities or special needs. It aims to ensure that everyone, regardless of their abilities, can access and interact with the designed elements effectively. The first and foremost thing is to define accessibility requirements for products and services, and that it's concrete and understandable in the form of personas and accessibility guidelines that can be applied to the development cycle. Get clarity on the range of personal, environmental, and task-related factors that should be addressed. Get to know that what is the range of users of this product, what are their abilities and limitations, and, under what circumstances will they use this product. Accessibility for the entire target user base, an interface requirement, should be integrated in the overall quality of the product, in the same way that the product functional description, functional requirements, contributes to its quality. On this strategy, the second thing is to ensure conformance to accessibility guidelines and established standards. Need products and services to be accessible to users with a very broad range of functional limitations, including persons of all ages or persons with disabilities. Accessibility implementation requires interoperability with assistive technology, et. Now we will talk about the work done by WCAG, that is Web Accessibility Initiative. WCAG works to ensure that people with disabilities can access the web using a wide range of devices, including desktop computers, mobile devices, and assistive technologies like screen readers, Braille displays, and speech recognition software. The goal of the WCAG is to develop guidelines, standards, and resources that will help web developers create websites and web applications that are accessible to everyone, regardless of their physical or cognitive abilities. Web accessibility depends on several components working together, including web technologies, web browsers, and other user agents, authoring tools, and websites. Web Accessibility Initiative is W3C's effort to improve accessibility of the web for people with disabilities. WCAG develops accessibility standards and offers implementation guidance. It pursues accessibility of the web through primary activities. Web Content Accessibility Guidelines, WCAG, and Accessible Rich Internet Applications, WCAG ARIA. WCAG guides on right implementation of web accessibility. Websites, tools, and techniques are designed and developed so that people with disabilities can use them. Perceive, understand, navigate, and interact with the web. People can contribute to the web. Now, let's deep dive into web accessibility part. Web accessibility refers to the practice of designing and developing websites and web applications in a way that ensures people with disabilities can perceive, understand, navigate, and interact with them effectively. This means that web content, such as text, images, audio, and video, must be presented in a way that is accessible to everyone, regardless of their physical or cognitive abilities. Number 1. It's important to provide equal access to information and functionality. Equal access to information and functionality requires making websites and web applications accessible to a wide range of assistive technologies and devices, as well as designing user interfaces that are easy to use and navigate. When sites are designed, developed, and edited correctly, all users would have equal access to information and functionality. The web is fundamentally designed to work for all people, that include all people no matter what their hardware, software, language, culture, location of physical or mental ability. Number 2, it's an essential requirement and there's a strong business case. Access to the web has become an essential requirement for full participation for the information society. It overlaps with other best practices such as mobile web design, usability, design for older users and optimized searches. It helps on SEO with better search results, reduced maintenance costs and increased audience reach. Here we will understand few examples of web accessibility. The most common set of things to ensure on your journey to web accessibility implementation. Keep navigation the same on each page. Keeping the navigation the same on each page is a good web accessibility practice because it helps users to understand and navigate the website more easily. Have a way for the user to increase/decrease font on pages. Having a way for the user to increase or decrease font on pages is a good web accessibility practice because it helps users with visual impairments to read and access content more easily. Have a high enough contrast between background color and text color. Having a high enough contrast between the background color and text color is an important web accessibility practice because it ensures that content is legible and easy to read, especially for people with low vision or color blindness. Have alternative text for graphics and videos. Providing alternative text for graphics and videos is an important web accessibility practice because it enables users with visual impairments to understand the content of the website, even if they are unable to see the images or videos. Alt text for images and charts. Captions and / or transcripts for videos. Have links that make sense. Avoid click here as link text. Having links that make sense and avoiding click here as link text is an important web accessibility practice because it helps users with disabilities, such as those using screen readers, to understand the purpose of the link and navigate the website more easily. Forms and tables should be properly formatted and labeled with the correct HTML. Properly formatting and labeling forms and tables with the correct HTML is an important web accessibility practice because it enables users with disabilities, such as those using screen readers, to understand the structure and content of the page. Content. Relevant content for the page with the relevant page titles. Heading markup. Correct HTML markup for relevant content. Have an alternative way to access the information for scripts, applets, and plugins. Providing an alternative way to access the information for scripts, applets, and plugins is an important web accessibility practice because it enables users with disabilities, such as those using assistive technology, to access the content of the website even if they are unable to interact with these technologies. Offer information in plain text format when possible. PDFs and Flash files are not easily accessible. The most accepted format is text because text can be consumed in different forms, like text-to-speech is one use case. Do not use different colored text to convey meaning. Only having color codes to convey the meaning is a common mistake that people do. WCAG focus on enabling access for people with disabilities, their special needs, and enabling access through the use of assistive technology. Let's talk about benefits of WCAG compliance. The use of research and development in accessibility brings benefits to everyone, like people using mobile phones, smart watches, smart TVs, and other devices with small screens, different input modes, etc. Older people with changing abilities due to aging. People with temporary disabilities or situational limitations. Top benefits of having WCAG compliance in our applications is: avoids discrimination and legal complications. Builds positive public relation. Better SEO, search engine optimization. Improves usability for all types of visitor. Broadens your market penetration. It's important to highlight here that though primarily focused on accessibility of content on the web, WCAG standard inform how content in other contexts should be made accessible. For example, MS Office documents, PDF, etc. Now, we will discuss about approach for accessibility testing. Testing a web page or website for accessibility compliance involves different kinds of testing methods, tools, and testers for each type. You need a combination of all to get a feel for the whole picture. Testing using tools. This involves use of a variety of tools to gather initial level problems. 2. Manual testing. This involves using assistive technologies, such as screen readers, keyboard-only navigation, and voice recognition software, to test web content for accessibility. Manual testing can help identify issues that automated testing may miss and ensure that web content is accessible to a wide range of users. AT testing and cross-browser testing. AT testing stands for Assistive Technology Testing. Assistive technologies are software or hardware tools that help people with disabilities to access and interact with digital content, such as screen readers, speech recognition software, and braille displays. Cross-browser testing. Cross-browser testing is the process of testing a website or web application across multiple web browsers and their different versions to ensure that it works correctly and consistently across all browsers and devices. Some important things to ensure that your product and services works with it. Testing with keyboard only, i.e. without mouse. Testing with more than one screen reader. Testing with more than one browser. Now we will talk about the use of tools in testing for accessibility. Variety of tools can be used to gather initial level problems against WCAG standard, however no single automated web accessibility checker can identify all potential barriers. Use of semi-automated tools. Tools that help to identify first-level gaps. WCAG standard on per-page basis or does crawling. Performs checks against each success criteria and reports on the potential barriers. Various kinds of tools checks for the presence or absence of semantic structure in given HTML. Such automated checkers do not do well, as far as meaning is involved, where a human will generally need to make those decisions. Use of helper tools like color contrast checkers, makes use of contrast algorithm to produce a color contrast ratio. Readability testing tools, generates score using length of words or sentences, the density of words or clauses, etc. Markup validation tools, identify broken or incorrect usage of HTML that affects its ability to read web content. Now let's understand the need for manual testing in accessibility testing. This involves in-depth testing against each success criteria in WCAG 2.0 and WCAG 2.1 guidelines. The basic testing strategies covers: Tab key navigation test, follow the focus indicator to keep track of where the user is within the page. Select all test, help identify elements in web content that are not keyboard accessible. Code examination and repair involves the examination of source code. Media review examining the captions, audio description, and transcripts. Then more deeper analysis and specific tests are to be done against the potential barriers identified. For each of the potential barriers, conduct tests and perform in-depth analysis to uncover HTML markup issues. Testing is needed on different form factor and responsiveness with larger text and no horizontal scrolling. And, importantly, testing by the actual PWD user requires. Testing with multiple screen readers needs to be done. Testing with multiple browsers needs to be done. At testing and cross-browser testing. Screen readers work best when paired with the browsers with which they are most compatible with. The list of recommended browsers and it to be tested includes JAWS. It works well with Chrome, Edge, Firefox, and Internet Explorer. NVDA. It works well with Firefox, Chrome, and Edge. Narrator. It works best with Microsoft Edge. VoiceOver. It works best with Safari. Cross-browser testing includes Chrome, Firefox, Safari, and Edge, which was earlier Internet Explorer. Web Content Accessibility Guidelines, WCAG, explains how to make web content more accessible to people with disabilities. WCAG covers websites, applications, and other digital content. It is developed by the World Wide Web Consortium, W3C, Web Accessibility Initiative, WAI. WCAG is an international standard. Let's first understand the accessibility principles, which is commonly abbreviated as POUR principles. Principle 1. Perceivable. This means that web content is made available to the senses, sight, hearing, and or touch. Information and user interface components must be presentable to users in ways they can perceive. This means that users must be able to perceive the information being presented and that information cannot be invisible to all of their senses. Examples of Principle 1: Perceivable information and perceivable user interface. Visually impaired users must be able to receive information via sound or touch. Hearing impaired users must be able to receive information via sight. Low vision users must be able to receive information with alternative formatting or zoomed to larger sizes. Color deficient users must be able to receive information without use of color. Principle 2: Operable. This means interface forms, controls, and navigation are operable. User interface components and navigation must be operable, i.e., users must be able to operate the interface. Further, the interface cannot require interaction that a user cannot perform. Examples of Principle 2: Operable information and operable user interface. Functions triggered via mouse or gesture are also available via a keyboard. All users are given sufficient time to read and use content. Content does not induce seizures. Users are given mechanisms to skip repetitive content. Landmarks are provided to assist in screen reader navigation. For example, meaningful page title, semantic headings, ARIA landmarks, meaningful headers, and meaningful and unique link text. Multiple paths are provided to navigate website structure. Principle 3: Understandable. Information and the operation of user interface must be understandable. This means that users must be able to understand the information as well as the operation of the user interface. The content or operation cannot be beyond their understanding. Examples of Principle 3: Understandable information and understandable user interface. Site is free of unannounced pop-up windows. Separate submit or go buttons/links are provided to initiate page changes, in place of using auto-submit upon selection. Navigation and labels are consistent across a website or application. Mechanisms are available to detect errors and provide clear instructions to users on fixing errors. Language of text or subsection of text is identified. Principle 4: Robust. This means that content can be used reliably by a wide variety of user agents, including assistive technologies. Content must be robust enough that it can be interpreted reliably by a wide variety of user agents, including assistive technologies. This means that users must be able to access the content as technologies advance. Further, as technologies and user agents evolve, the content should remain accessible. Examples of principle for robust content and reliable interpretation. Content must be compatible with different browsers and assistive technologies. Markup should be valid. In structure of WCAG 2.1 standard has 78 success criteria broken into 3 levels of conformance, that is, A minimum level, AA recommended level, AAA advanced level, which leads to best and most accessible products and services. An exact structure goes like: total principles equals 4. Total guidelines equals 13. Total success criteria equals 78, that is, Level A, which covers 30 success criteria. Level AA, which covers 20 success criteria. Level AAA, which covers 28 success criteria. And here we have the revised version of WCAG. Changes from WCAG 2.1 to WCAG 2.2. It provides 9 additional success criteria. And now total success criteria is equals 87. Level A, which covers 32 success criteria. Level AA, which covers 24 success criteria. Level AAA, which covers 31 success criteria. These 3 levels of conformance are cumulative. Level A is the first and minimum level. Level AA is the next, and it includes all Level A and AA requirements. Many organizations strive to meet Level AA. Level AAA includes all Level A, AA, and AAA requirements. Accessibility makes a difference in the lives of real people. Whenever possible, we should think through the full implications of our designs, and not just the technical accessibility, and feel free to incorporate WCAG level AAA ideas to leading accessibility groups, and to even go beyond WCAG to incorporate best practices for disability usability. We must be consistent and accurate in interpreting what is and what is not a failure of WCAG. It is important to ensure that we are correctly interpreting the guidelines and also deal with false positive or false negatives. For each WCAG guidelines, success criteria, SC, are written as testable statements that are not technology specific. Now for each WCAG success criteria, we will find the interpretation in the form of checkpoints. These checkpoints are a proven method for accessibility requirements testing and help reviewers produce consistent and accurate test results during accessibility assessments. Conformance levels to WCAG standard. Just to recap here. WCAG level A is beginner. WCAG level AA is intermediate. WCAG level AAA is advanced. Note: although conformance can only be achieved at the stated levels, authors are encouraged to report, in their claim, any progress toward meeting success criteria from all levels beyond the achieved level of conformance. WCAG Level A Basic Accessibility, i.e. the lowest and easiest level of conformance to obtain. This is considered the least strict. Level A success criteria are essential for every website. If your website doesn't conform with WCAG Level A, it may have serious accessibility issues that prevent users with disabilities from using it. At this level, within the current guidelines WCAG 2.2, there are 30 criteria that organizations must meet. An example of the criteria includes: non-text content, images, and videos, must have a text equivalent. Users must be able to access content using a keyboard only. Forms must include labels or instructions, so users know what's expected of them. Assistive technologies, such as screen readers, must be able to access content. Information or instructions must not be conveyed through shape, size, or color alone. WCAG Level AA Strong accessibility, where we have the mid-range and most common level of conformance to obtain. While WCAG Level A allows organizations to cover the basics, WCAG Level AA goes further toward making web content accessible for users in a wider variety of contexts. It is for this reason that most accessibility experts recommend this conformance level. As a reminder, at this conformance level, the web page and content would satisfy all Level A and Level AA success criteria. At Level AA, criteria includes all that is outlined at Level A plus an extra 20 requirements. Examples include: text and background must use good color contrast. For example, have a minimum level of contrast of at least 4.5 to 1. Content should be organized under clear headings, using a logical order. For example, a H1, followed by H2, H3, etc. Elements that affect navigation should be consistent across the site. WCAG Level AAA Excellent Accessibility. Level AAA is the highest possible conformance level in WCAG, and as a result holds organizations to the highest standard of accessibility. At this level, the web page and content satisfy all Level A, Level AA, and Level AAA success criteria. Although Level AAA may not be applicable or realistic for everyone to achieve, organizations should strive to meet as many of its criteria as possible. Level AAA criteria outlines an extra 28 requirements from those outlined at Level AA. Examples include: contrast ratio between text and background is at least 7 to 1. Pre-recorded video content must have a sign language translation. Extended audio description should be provided for pre-recorded videos. This is to sum up the understanding on WCAG structure. Total principles 4. Total guidelines 13. Total success criteria 87 for each guideline. We have Level A, Level AA and Level AAA success criteria represented here. This is yet another representation, where web content accessibility guidelines structure is explained. Again, it is evident that total principles 4. Total guidelines 13. Total success criteria 87. For each guideline, we have Level A, Level AA and Level AAA success criteria represented here. Now let's understand the 10 key accessibility success criteria for accessibility conformance as per WCAG 2.2 standard. 1. Non-text content, which is mapped to SC 1.1.1, Level A. This means that any non-text content, such as images, videos, or audio files, should have text alternatives that describe what the content is. This allows people who cannot see the non-text content to still understand what is happening on the page. For example, an image of a cat could have the text alternative "A cat is sitting on a rug." Here are some examples. Images, photographs, illustrations, logos, diagrams, and other visual content that conveys information or aesthetics. Videos, short or long-form video content, such as tutorials, product demonstrations, interviews, or documentaries. This success criteria is perhaps the most important of the all in WCAG 2.0 in terms of reducing potential barriers. It is relevant to making content accessible to those who are blind. Generally speaking, it requires that all meaningful visual content include an equivalent text alternative. The best way to make photographs, images, and other non-text content accessible to those who are blind is to provide text alternatives. It's because text alternatives are easily translated into forms that individuals, whatever their needs, can understand. A person who is blind can read the text with a screen reader or convert the text to Braille. A person reading in a second language can translate the text. A person with low vision can magnify the text without it losing its crisp appearance. The text can be indexed by search engines to make images searchable, and so on. Text alternatives can take on a variety of forms. Alt text is an attribute associated with the HTML/IMG element. It should contain a short description of the meaningful elements of the image, up to a maximum of 125 characters. All images must have an alt attribute to conform with this guideline, even if an image is decorative and contains no useful information. For meaningless images, the value for alt is left empty, e.g., alt equals This forces assistive technologies to ignore the image. If the alt attribute is missing, assistive technologies will announce the file name for the image, which will often interfere with comprehension of the relevant surrounding content. The only times the alt attribute should be left blank is when the non-text content is 1. Purely decorative. 2. Used only for visual formatting. 3. Not presented to users. 4. A test or exercise where the alt text would affect the outcome. Key points. All images must have an alt attribute, regardless of whether they are meaningful or not. Images missing alt will fail the underlying guideline with this success criteria 1.1.1. Alt text must be no more than 125 characters in length. Assistive technologies will stop reading at this point, and move on to the content that follows. 2. Time-based media, which is mapped to SC 1.2.2, Level A. Time-based media refers to audio content or video content or audio and video content combined. This success criteria is relevant to combined media, and making the audio tracks within that media accessible to those who are deaf. That means when video has meaningful audio content, particularly spoken content, that content must be accompanied by synchronized captions to conform with this guideline. When video has meaningful audio content, particularly spoken content, that content must be accompanied by synchronized captions to conform with this guideline. Closed captions, these are captions contained in a text file with time intervals, along with the text to display during each interval. Providing closed captions for television is the law in many jurisdictions. There are also many places that now require captions on internet-based video, part of web accessibility legislation based on this particular WCAG guideline. Open captions, unlike closed captions that can be turned on and off and are available in a separate text track in a video, open captions are burned right into the video, and cannot be turned off or otherwise separated from the video. Either type of captions will meet the success criteria for this guideline, though closed captions are a better choice where possible because they are more adaptable. Closed captions can easily be converted into a transcript or translated and swapped with a different language to create subtitles. Descriptive text describing meaningful visual elements in a video can be added to captions to be read by screen readers and take the place of audio description. Key point: captions are required by law in many jurisdictions. In Ontario, the AODA makes it mandatory to include captions with pre-recorded video. 3. Info and relationships, which is mapped to SC 1.3.1, Level A. The Info and Relationships guideline requires that the structure and relationships of content be made programmatically determinable. This means that the structure and relationships of the content should be understandable by assistive technologies, such as screen readers. Here is an example of how the Info and Relationships guideline might be applied to a web page. Let's say you have a web page that contains a list of products. The list of products is organized into categories, and each product has a name, price, and description. To make the structure and relationships of this content programmatically determinable, you would need to do the following. Use headings to mark the different sections of the page, such as categories, products, and description. Use lists to display the products and use the item prop attribute to indicate the product's name, price, and description. Use the ARIA label attribute to provide alternative text for any non-text content on the page, such as images or videos. Structuring of content is typically accomplished by using HTML heading markup, H1, H2, etc., to create topics and subtopics, though there are a variety of other ways to structure and express the relationships between elements on a web page. It is another way for assistive technology users to navigate by keyboard. Headings are used to represent the structure of topics and subtopics, to assist in organizing the content in a meaningful way to aid understanding and comprehension. Let's talk about headings. Headings. So, when a screen reader user lists the headings on a page, it provides information about the topics on the page and related subtopics for each. A screen reader will announce the text of the heading as well as its heading level, 1 to 6. This can provide a quick overview of the page, and create relationships between topics and subtopics, before the user decides how to proceed through the content. If headings are not provided, or they are used incorrectly, understanding the content becomes more difficult. When headings are used, they should be nested correctly. For example, an H1 should be followed by an H2, or another H1. An H2 should be followed by an H3, or an H2 or H1. An H3 should be followed by an H4, or an H3, H2, or H1, and so on. Heading levels should not be skipped when traversing down through a heading list, e.g., H2 should not be followed by H4. Key point: properly nested headings, using HTML heading markup, should be used to structure topics and subtopics within a web page, rather than using otherwise styled large bold text. Lists. Another way to structure content to aid understanding is to arrange sequences or collections of related items in lists, using HTML list markup, i.e., ul, ol, li, etc. So when a screen reader encounters a list, it will announce the presence of the list and the number of items it contains. While navigating through the list, the cursor's position in the list will be announced, e.g., item 4 of 7. Having this structural information can aid comprehension when one cannot see the visual structure of the list. Avoid using split lists, in which items are numbered throughout a page, separated by other content, with each item a new list starting at a different number. Though these may look like a list when viewed, when read by a screen reader, each will be announced as a new list with only one item, rather than as part of a larger list. When creating lists, use an ordered list, OL, only when the order in which list items appear is important. Otherwise use an unordered list, OL. Key point: if a collection of items on a page looks like a list, ensure that list markup has been used to create the list, rather than using simple line breaks after each item. Form labels. Relationships between form labels and their respective input fields should be created using the HTML label element and explicitly associating the two by matching the ID attribute value of the input field with the for attribute value of the label element. Technically, this means that you need explicitly associate form labels with their respective form input fields by matching the for and ID attributes, respectively, as follows. Label for equals username login name / label. Input type equals text ID equals username /. When form elements are explicitly labeled in this way, it ensures that regardless of where the label appears on the screen, which may change if a screen is magnified or is being viewed on a smaller device, when a screen reader encounters the input field, it will be announced label properly. Another advantage of using explicit labels is that the labels become clickable to send focus into the input field. This can be helpful for those who may have trouble targeting a small input field, e.g., a radio button or a checkbox, with a mouse pointer, giving them a larger target area to click to activate the form element. Related form fields can also be grouped using a field set element, and labeled with the legend element. For example, in a registration form, all account information can be grouped, personal information can be grouped, and perhaps address information can be grouped. In each case, the legend element gets announced by it along with the form element's label, clarifying the meaning and relationship between elements within the group. Table headers. When navigating through a table in web content that lays out a series of columns and rows to arrange data or a collection of related information, it is important that the first row, and potentially the first column, are created using the HTML table header element, th. When navigating through the data cells, td, with the screen reader, the header cells can be announced along with the content of the data cell. This can be particularly important for larger tables where it becomes increasingly more difficult to keep track of one's location within the grid of cells. Technically, this would mean that you need to ensure that data tables use table header elements at the top of each column, and in some cases, at the start of each row. Tables used to lay out non-data content should be avoided. Though in many cases layout table can be accessible, using div elements to lay out content is a much more adaptable strategy. They will accommodate a wider range of technologies, e.g., those with small screens, and adapt more easily to individual user needs. Elements wrap when the screen is magnified, for example, and stay in view rather than getting pushed off the side of the screen. There are many ways to express information about relationships in web content. Those listed here are the main ones. Meaningful sequence, which is mapped to SC 1.3.2, Level A. The Meaningful Sequence WCAG guideline requires that the order of content on a web page must be meaningful and can be programmatically determined. This means that the order of the content must make sense and that it must be possible for a computer to determine the correct order. For example, a recipe website should have the steps in the recipe in a logical order. The ingredients should be listed before the steps, and the steps should be in the order that they need to be followed to make the recipe. This way, someone using a screen reader or other assistive technology can easily follow the recipe. Another example is a blog post. The paragraphs in a blog post should be in a logical order, and the headings should help to indicate the order of the content. This way, someone can easily scan the post and find the information they are looking for. A meaningful sequence when navigating through a web page using a keyboard is from left to right, top to bottom, much like the path the eyes take when reading a book. There are times when what appears to be a logical path or sequence in web content when viewed, becomes illogical when read by assistive technologies navigating through the content with a keyboard. The logical sequence for most web content should move from top left to right, from the top of the page to the bottom. An example of an illogical sequence occurs when elements are reordered using CSS. Visually the content may appear to flow from left to right, but when navigating with a keyboard, the cursor may jump around the screen. For those with low vision, who may have the screen resolution magnified several times to make the screen more visible, content often appears out of view off to the side of the screen. If they are using the tab key to navigate through links and forms, they will expect the above sequence and go looking for the cursor's focus off to the right, or back to the left after reaching the far right of the screen. If the cursor does not follow the usual sequence, the user can have considerable difficulty finding it when it leaves the visible area of the screen. Another example is modal dialog boxes. One particularly common barrier occurs when developers add modal dialog boxes to web content. These boxes typically open over top of the page being viewed, with the content of the page below faded to bring visual focus to the contents of the box. For screen reader users, the cursor's focus often remains on the page hidden behind the box, rather than moving into the box itself. When a modal dialog box is opened, the proper sequence is to send the cursor's focus to the first element within the box, and when navigating through the box, the focus should remain inside it until the required action has been completed. Once the action has been completed, the cursor's focus should then be sent back to the page below to the position where the box was originally opened from. Key point: a meaningful sequence when navigating through a web page using a keyboard is from left to right, top to bottom, much like the path the eyes take when reading a book. 5. Use of color, which is mapped to SC 1.4.1, Level A and SC 1.4.3, Level AA. While the use of color can help to add meaning to web content, the use of color on its own to represent meaning can create a barrier for those who cannot see color, including those who are blind, colorblind, or have low vision. Color can also be problematic when text of one color appears over a background of another color, and the contrast between the two is insufficient. Contrast is included here as color usage, though it is addressed by Success Criteria 1.4.3 at Level AA, and Success Criteria 1.4.6 at Level AAA. 1.4.1 Use of color. Color is not used as the only visual means of conveying information, indicating an action, prompting a response, or distinguishing a visual element. The visual presentation of text and images of text has a contrast ratio of at least 4.5:1, with few exceptional conditions. This means that if you are using color to convey information, such as indicating that a field is required or that an error has occurred, you should also provide a way for users who cannot see color to understand the information. You can do this by using text labels, icons, or other non-visual cues. For example, if you are using red text to indicate that a field is required, you should also include a label that says required next to the field. This way, users who cannot see color will still be able to understand that the field is required. SC 1.4.3 Contrast. Minimum. It requires that all text and images of text have a contrast ratio of at least 4.5:1. This means that the difference between the foreground color and the background color must be at least 4.5 times greater than the smallest possible difference between those colors. For example, if the foreground color is black, the background color must be at least number 333,333, dark gray. There are a few exceptions to the 4.5:1 contrast ratio requirement. For example, large text, 1/8px or larger, only needs a contrast ratio of 3:1. Additionally, text that is part of a logo or brand name does not need to meet the contrast ratio requirement. Exceptions to this contrast ratio requirement of at least 4.5:1 includes the following. Large text. Large-scale text and images of large-scale text have a contrast ratio of at least 3:1. Incidental. Text or images of text that are part of an inactive user interface component, that are pure decoration, that are not visible to anyone, or that are part of a picture that contains significant other visual content, have no contrast requirement. Logotypes. Text that is part of a logo or brand name has no minimum contrast requirement. The most common form of color blindness is red/green insensitivity. For such people, a red stop button and a green start button may not be distinguishable from one another. To avoid this potential barrier, the red button should have the word stop added to it and the green have the word start added to it. Another common barrier results when error messages are presented in red color alone, without some other indicator of the error. Think about what happens if a person with a common form of color blindness submits a form, but leaves some of the required fields empty. He or she would receive a returned form with the missing fields highlighted in red and the correct fields highlighted in green, but would not be able to tell them apart. For a visually impaired person, red color alone doesn't help. Taking about contrast issues, technically, it is often possible for those with full sight to intuitively identify when contrast between text and background is insufficient. There are many tools available to measure color contrast that compare two color codes, e.g., number FFFFFF or number 000000 for white and black. Where there appears to be insufficient contrast, the color codes for the text and background should be tested. These color codes can be found most easily by right-clicking on an element, then choosing Inspect Element from the browser's pop-up context menu, then examining the CSS elements in the right pane of the inspector. The requirement for conformance with Level AA is a contrast ratio of 4.5:1 for smaller-sized text and 3:1 for larger text. 6. Keyboard accessible, which is mapped to SC 2.1.1, Level A. Keyboard Accessible Guideline of WCAG, Web Content Accessibility Guidelines, states that all functionality of a web page should be accessible using only a keyboard. This means that users who cannot use a mouse or other pointing device, i.e. those who are blind or have low vision, as well as those with mobility impairments, they should still be able to navigate and interact with the page by using keyboard. Here is an example of how to make a web page keyboard accessible. Use focus indicators. When a user tabs through a page, focus indicators should be used to show which element is currently focused. This will help users know where they are on the page and what they can do next. Make all links clickable. All links should be clickable using the keyboard, even if they are styled to look like images or other non-clickable elements. Use keyboard shortcuts. Keyboard shortcuts can be used to perform common tasks, such as opening new tabs, navigating back and forth, and searching for text. Keyboard. All functionality of the content is operable through a keyboard interface without requiring specific timings for individual keystrokes, except where the underlying function requires input that depends on the path of the user's movement and not just the endpoints. Level A. Note 1. This exception relates to the underlying function, not the input technique. For example, if using handwriting to enter text, the input technique, handwriting, requires path-dependent input but the underlying function, text input, does no. Note 2. This does not forbid and should not discourage providing mouse input or other input methods in addition to keyboard operation. Implementing keyboard access is done using event handlers, which can be mouse-specific, e.g., on mouse over, or keyboard-specific, e.g., on keypress, or they can be device-independent, e.g., on focus, working with either mouse or keyboard actions. When developing custom interactive elements in web content, developers tend to use device-independent event handlers whenever possible or may use both mouse and keyboard event handlers together. 7. Provide ways to navigate, which is mapped to SC 2.4.1, Level A. This WCAG guideline Provide Ways to Navigate is about making sure that your website or web application is easy to navigate for people with disabilities. This includes people who use screen readers, magnifiers, or other assistive technologies. There are a few things you can do to meet this guideline. Use headings and labels. Headings and labels help people with screen readers understand the structure of your content. For example, you could use a heading to identify the main topic of a section of text, and then use labels to identify the individual elements of that section, such as images, tables, and forms. Provide a sitemap. A sitemap is a list of all the pages on your website, organized by topic. This can help people with disabilities find the information they need quickly and easily. Implementation of this guideline would mean that a mechanism is available to bypass blocks of content that are repeated on multiple web pages. No content should be orphaned outside of a landmarked area. Also, where HTML5 equivalent elements are used, a landmark role is not required. By providing ways of navigating around within pages makes it possible to move through elements on a page more quickly, simulating visual scanning for those who are blind. Within-page navigation can also make navigating more efficient for those who rely on a keyboard. While bypass blocks provide the ability to skip past blocks of repetitive content, like large complex menus or long lists of links, it's better to think in terms of within-page navigation to improve accessibility for those who are unable to scan and click. For screen reader users, proper use of headings H1, H2, etc. and it's an easy way to provide within-page navigation. Screen readers then list the headings on a page, allowing the user to navigate through the list to a particular heading, then press the Enter key to jump directly to the heading on the page. You may encounter bypass links, which were used historically to help screen reader users navigate page content. With this strategy, an invisible image with alt text such as Jump to Main Content was placed in the top left corner of a page and linked to an anchor at the beginning of the main content. Bypass links might also be hidden links that appear when they receive focus, so sighted keyboard users can also make use of them. While bypass links do satisfy the criteria for this guideline, today you are more likely to encounter ARIA landmarks, a particular set of ARIA roles that can be added to various elements to define their purpose, and provide the ability to jump to different regions of the page. The equivalent to the main content bypass link described above is the ARIA landmark main, which would be added as an attribute to the main element containing the primary content of the page. Screen readers can list the landmarks on a page, much like they can list the headings on a page. Use the down arrow until main is announced, then press Enter to jump to the main content region. Technically, it requires you to mention the role attribute, wherever applicable. For example, main landmark is specified as div role equals main. Main content goes here. /div. Navigation landmark is specified as ul role equals navigation. Lee home /Lee. Lee products /Lee. etc. ul. Full list of landmark roles includes banner, typically associated with the header area of a page. There should only be one banner landmark per page. Complementary, a section of content that complements the main content but also retains its meaning when separated from the main content. Often used with a region containing advertising or promo items aligned down the right side of the page. There can be multiple areas defined as complementary. Content info, contains the content usually found in the footer of a page, like copyright and privacy statements. There should only be one content info landmark per page. Form contains form input elements that can be edited and submitted by the user. Multiple elements can have the form role. Main, the main content of the page. There should only be one main landmark per page. Navigation, a collection of navigation links used to navigate the site or page. There can be multiple elements with the role navigation. Search, a search tool. There can be multiple search tools. Application, represents a unique functional unit, and keyboard commands are handled by the application rather than the browser or the assistive technology itself. An embedded movie player, a calendar widget, or other customized software embedded in web content, are examples where the application role might be used. This role should be used sparingly as it can create some confusion for screen reader users when key commands begin working differently. When using landmarks, each area of the page should be enclosed in elements that have a landmark role associated with them. No content should be orphaned outside of a landmarked area. Also, where HTML5 equivalent elements are used, a landmark role is not required. For example, when using HTML5 header, the banner role need not be added. When using HTML5 nav, the navigation role need not be added. When HTML5 footer is used, the content info role need not be added. Similarly, do not use the form role in a form element. It already has a role of form associated with it as part of the HTML specification. Another example is within page navigation. There are a few other cases when within page navigation can be added to improve accessibility. When there are embedded objects like a movie player or some interactive flash, assistive technology users can benefit from a bypass link just before the object, with appropriate alt text to describe the purpose, that when followed repositions the cursor after the object. Where complex or large tables of data are presented, a bypass link can be provided to allow users to skip over the table. Without these added bypass links, navigating past these embedded objects can be time-consuming. 8. Link purpose, in context, which is mapped to SC 2.4.4, Level A. This guideline of WCAG 2.1 requires that the purpose of each link on a web page be understandable from the link text alone, or from the link text together with its programmatically determined link context. This means that users should be able to understand what a link will do without having to read the surrounding text or use assistive technology to get more information. For example, a link to a product page should have link text that says something like product page or view product. A link to a blog post should have link text that says something like blog post or read blog post. And a link to a contact page should have link text that says something like contact us or get in touch. Implementation of this guideline would mean that the text of a link should be meaningful. The purpose of each link can be determined from the link text alone or from the link text together with it. When creating links, it is important that the text of a link be meaningful. If it is not, a person who is blind using screen reader may be required to read the text surrounding the link, or actually follow the link, in order to determine where it leads. Either requires extra effort for screen reader users and sighted users alike, that can be avoided by simply using text that describes the destination or function of the link. You have almost certainly come across links like click here or more in your travels through websites. These links on their own provide no useful information about the destination or function of the link. This particular guideline refers to links within context, meaning that there may be information in the surroundings that give meaning to these otherwise meaningless links. This should be distinguished from the requirements of Guideline 1.4.6, Level AAA, which requires link text to be meaningful regardless of context. In context, a link like more can be made meaningful by a link that precedes it. For example, many news sites will provide a short excerpt from an article, followed by a more link to read more about the topic. In such cases, if the title of the article is itself a link to the full article, that title gives meaning to the more link by virtue of its proximity. Screen readers will read the title link first followed by the more link, then read the next title then more, and so on. In such cases it is relatively easy to make the connection between the article title and the otherwise meaningless more link. In such cases the more link is acceptable for level A conformance. Screen readers will have a function that allows a user to list the links on a web page. The user can listen to the link text for each and jump directly to a link of interest. If those links are a series of click here links, that link list becomes unusable if there are no surrounding links present to add meaning. Screen readers can also sort a list of links alphabetically. In such cases, any context that might have been provided by surrounding links, such as news article titles in the example above, are lost. Hence at level AAA, Guideline 1.4.6 requires that link text be meaningful on its own. Though the level A requirement is only that link text be meaningful in context, it is good practice to use link text that is meaningful on its own. This will make the links more usable for everyone, including those with full sight, who also have to resort to searching the surrounding text to figure out where a click here link leads. Key point: link text should describe the destination of a link or its function if it operates a feature of a web page. Do not use click here as link text. 9. Error identification, which is mapped to SC 3.3.1, Level A. The Error Identification Guideline of WCAG 2.1 requires that web content developers provide clear and understandable error messages to users when they make mistakes in forms or other input fields. This is important for all users, but it is especially important for users with disabilities, such as visual impairments or cognitive impairments. If an input error is automatically detected, the item that is in error is identified and the error is described to the user in text. Level A criteria. If a user makes an error when filling out a form, a message identifying the error usually appears. It is important that forms are created in such a way that screen readers can find and read error messages, otherwise the forms become unusable. When an error occurs after submitting a form, there are a variety of different ways to present the error messages. A common strategy is to present a short message next to the fields that were missing, such as required field left empty. Another is to display a box near the top of the page that lists the errors that have occurred. Typically, the form is submitted and the page reloaded before the messages are displayed, in which case a screen reader would begin reading the page once more from the top left. At that point the user would have no idea that an error had occurred, and would only discover this by navigating into the page. In addition to presenting error messages in a way that screen readers can detect them, success messages should also be used where feasible, to indicate that a particular action has completed successfully. For instance, after completing a registration form successfully, present the message "You are now registered" or something to that effect. This removes the need to search through the page that loads after submitting the form to determine whether it was successful or not. Key point: be sure that screen reader users are aware of feedback messages. Use the ARIA role equals alert on dynamically injected messages so they get read automatically. Here is an example of how to implement the error identification guideline. Identify the error. The first step is to identify the specific error that the user has made. This can be done by using a combination of techniques, such as checking the length of the input, the format of the input, and the value of the input. Provide a clear and understandable error message. The error message should be clear and easy for the user to understand. It should also be specific enough to help the user correct the error. For example, if the user has entered an invalid email address, the error message could say the email address you entered is not valid. Please enter a valid email address. Use appropriate visual cues. For users with visual impairments, it is important to use appropriate visual cues to indicate that an error has occurred. This can be done by using color, font size, or other visual indicators. 10 Labels and instructions, which is mapped to SC 3.3.2, Level A. The Labels and Instructions WCAG guideline requires that all interactive elements on a web page have labels or instructions that clearly explain what they do. This is important for people with disabilities, who may not be able to see or understand the visual cues that are typically used to identify interactive elements. In addition to labels, it is often necessary to provide additional information or instructions on how the form or other interactive elements should be used. Instead of making screen reader users navigate through a form, complex menu, or other interface element to understand how its layout or function, provide instructions ahead of time. Key point: provide explicit instructions describing how things work, and associate those instructions with the relevant feature using ARIA describedb. Let's take an example of button that says Submit should have a label that explains what will happen when the user clicks on it. This could be something like Submit this form or Send this message. Similarly, a checkbox that says I agree to the terms and conditions should have an instruction that explains what the user is agreeing to. This could be something like by clicking this checkbox, you agree to the terms and conditions of use. Here are some additional tips for creating clear and concise labels and instructions. Use plain language that is easy to understand. Avoid jargon and technical terms. Be specific about what the user can expect to happen when they interact with an element. Use short labels and instructions. Place labels and instructions close to the interactive elements that they refer to. Suppose you are an auditor and you are asked to do a quick assessment and share the recommendations. What will be your approach? You are not going to conduct testing here, but look at the common practices that are being followed. Now let's see what are the 10 key problems observed by accessibility auditors. Observation number 1. Suppose you find images without a text description. Is it a problem? Yes. Recommendation: all images should be adequately described using text in alt attribute. Images that are decorative or contain no useful information, alt attribute should still be used, with alt equals. This is mapped to SC 1.1.1, Level A. Observation number 2. Suppose you find functional elements that only work with a mouse. Is it a problem? Yes. Recommendation: all functional elements should be operable with both a mouse and a keyboard. People who are blind or having low vision or power users rely on keyboard access. This is mapped to SC 2.1.2 Level A. Observation number 3. Suppose you find text that looks like a heading, but is not a heading. Is it a problem? Yes. Recommendation: all heading or section titles within web content should have proper HTML heading markup, H1, H2, etc. If not done, users face problems when listening to a heading list with a screen reader. This is mapped to SC 1.3.1 Level A. Observation number 4. Suppose you find links that do not describe the destination or function. Is it a problem? Yes. Recommendation: all links should describe the destination of the link, so as to make it identifiable without having to click the link to discover its destination. Like headings, screen readers would list all of the links on a page to gather a summary of the resources that lead from it. This is mapped to SC 2.4.4 Level A. Observation number 5. Suppose you find list that looks like a list, but is not a list. Is it a problem? Yes. Recommendation: use HTML list markup to format a collection of items. If the order of the items is important, an ordered list should be used, otherwise, use an unordered list. This is mapped to SC 1.3.1 Level A. Observation number 6. Suppose you find missing within page navigation. Is it a problem? Yes. Recommendation: be sure that there are ways to navigate around within web content, using potential ways like headings, bypass links, or landmarks, etc. This allows users to skip over repetitive elements. This is mapped to SC 2.1.1 Level A. Observation number 7. Suppose you find poor visibility, contrast, or use of color on its own. Is it a problem? Yes. Recommendation: be sure there is good contrast between text and background color, to make it readable. Be sure that cursor's focus location is easily visible, as indicator, when navigating by keyboard. When color is used to represent meaning, like green color code to start or red to stop, be sure there is some other indicator provided to express that meaning. This is mapped to SC 1.4.1 Level A and SC 1.4.3 Level AA. Observation number 8. Suppose you find video with no captions or automatic captions. Is it a problem? Yes. Recommendation. Be sure that videos be captioned to capture any meaningful spoken dialogue, and the audio or video content is made available to those who cannot hear or to include the users who are in a noisy environment. Captions must be created by a human being. YouTube or Vimeo hosting uses automated captioning in their video collections, by using voice recognition technology like sound to text. This is mapped to SC 1.2.1 Level A and SC 1.2.2 Level A. Observation number 9. Suppose you find information that updates without reloading the page. Is it a problem? Yes. Recommendation. Ensure that any updating information on a web page is formatted to be discoverable by screen readers using AriaLive. When updated content is presented on a web page, it must be formatted in such a way that screen reader users are informed of the changes. This is mapped to SC 1.4.2 Level A. Observation number 10. Suppose you find tables presenting data that have no row or column headers. Is it a problem? Yes. Recommendation. Be sure tables that are used to lay out data are formatted with proper headings using a proper table header cell, TH and HTML. Users navigating through tables containing data using a screen reader, follow the column or row headers to determine the meaning of data in a table data cell, TH. This is mapped to SC 1.3.1 Level A. Web Content Accessibility Guidelines, WCAG, explains how to make web content more accessible to people with disabilities. WCAG covers websites, applications, and other digital content. It is developed by the World Wide Web Consortium, W3C, Web Accessibility Initiative, WAI. WCAG is an international standard. Principle 1. Content must be perceivable. Information and user interface components must be presentable to users in ways they can perceive. Examples of Principle 1. Visually impaired users must be able to receive information via sound or touch. Hearing impaired users must be able to receive information via sight. Low vision users must be able to receive information with alternative formatting or zoomed to larger sizes. Color deficient users must be able to receive information without use of color. Guidelines for this principle. Guideline 1.1, Text Alternatives. Provide text alternatives for any non-text content so that it can be changed into other forms people need, such as large print, braille, speech, symbols, or simpler language. Guideline 1.2, Time-based media. Provide alternatives for time-based media. Guideline 1.3, Adaptable. Create content that can be presented in different ways, for example simpler layout, without losing information or structure. Guideline 1.4, Distinguishable. Make it easier for users to see and hear content including separating foreground from background. Reference: https://www.w3.org/tr/WCAG21/ number perceivable. Guideline 1.1 Text Alternatives, Level A. Provide text alternatives for any non-text content so that it can be changed into other forms people need, such as large print, braille, speech, symbols, or simpler language. How to implement. Provide text alternatives for any non-text content and should serve the equivalent purpose. Use alt tags for images and text descriptions for animations, 3D models, and other media. Use CAPTCHA alternatives. This is required of all web pages. There is only one section under this guideline, as follows. It is recommended that you refer to the WCAG Success Criterion 1.1.1 since this knowledge is needed to comprehend the rest of WCAG. Look through all of the sufficient techniques and common failures to obtain an idea of what to do and what to not do. References. Success Criterion 1.1.1 https://www.w3.org/tr/understanding WCAG 20/text-equivalent.html. Understanding Guideline 1.1 http://www.w3.org/tr/understanding-WCAG 20/text-equiv.html. Guideline 1.2 Time-based media, Level A. Provide alternatives for time-based media. How to implement. Provide captions for video. Provide audio transcriptions for audio. If you have any multimedia being made available through your web page, you must provide this multimedia in multiple ways that can satisfy each individual sense. Pre-recorded audio-only media has an alternative format such as text or visual, and pre-recorded video-only media has an alternative format such as text or audio. Captions are provided for all pre-recorded audio content. This allows hearing-impaired users to access the captions that are stored directly within the audio track. An alternative description is provided for the events happening in pre-recorded visual media. Therefore, all pre-recorded audio-only media has an alternative format, such as text or visual, and pre-recorded video-only media has an alternative format, such as text or audio. References. Understanding Guideline 1.2 http://www.w3.org/tr/understanding-WCAG 20/media-equiv.html. Guideline 1.2 Time-based media, Level AA. Provide captions for all live audio content in synchronized media. Provide an audio description for all pre-recorded video content in synchronized media. Guideline 1.2 Time-based media, Level AAA. Provide sign language interpretation for all pre-recorded audio content in synchronized media. Provide an extended audio description for all pre-recorded video content in synchronized media when audio descriptions can't convey the sense of the video. Also, provide an alternative for time-based media for all pre-recorded video-only media. Provide an alternative for time-based media that presents equivalent information for live audio-only content. Guideline 1.3 Adaptable. Create content that can be presented in different ways, like simpler layout, without losing information or structure. How to implement. Use appropriate semantic markup whenever possible for HTML documents, including header styles. Use appropriate markup for table headers. Use appropriate markup, including form labels, to identify form and application controls. Preserve the visual sequence of content even with disabled styles. Flash objects are implemented so that a screen reader will read them in the appropriate sequence. Guideline 1.3 Adaptable, Level A. This style of coding is called semantic markup, where the coding is organized and clear so that when everything else is stripped from your web page, such as CSS and layout tables, it maintains the desired information that the user wishes to obtain. Every web page is affected by this guideline. Section 1.3.1 Information, structure, and relationships conveyed through presentation can be programmatically determined or are available in text. Section 1.3.2 When the sequence in which content is presented affects its meaning, a correct reading sequence can be programmatically determined. Section 1.3.3 Instructions provided for understanding and operating content do not rely solely on sensory characteristics of components such as shape, size, visual location, orientation, or sound. References. Understanding Guideline 1.3. Guideline 1.3 Adaptable, Level AA. Don't restrict content view and operation to a single display orientation, portrait, or landscape, unless a specific display orientation is essential. The purpose of each input field collecting information about the user should be easily identifiable. Guideline 1.3 Adaptable, Level AAA. Ensure the purpose of user interface components, icons, and regions can be programmatically determined. Guideline 1.4 Distinguishable. Make it easier for users to see and hear content, including separating foreground from background. How to implement. Ensure appropriate contrast between text and background. Ensure that content is distinguishable independent of color. Avoid automatically playing audio, slideshows and animation. Provide play buttons instead. Use CSS formatting instead of graphics to format text whenever possible. Guideline 1.4 Distinguishable, Level A. Required for all web pages. This guideline has a simple premise of making the presentation of your web page's information easily perceived to those with disabilities. Section 1.4.1, Color is not used as the only visual means of conveying information, indicating an action, prompting a response, or distinguishing a visual element. Section 1.4.2, Provide a mechanism for controlling audio volume independently from the overall system volume level for any audio on the web page. If any audio on a web page plays automatically for more than 3 seconds, either a mechanism is available to pause or stop the audio, or a mechanism is available to control audio volume independently from the overall system volume level. References. Understanding Guideline 1.4. Guideline 1.4 Distinguishable, Level AA. Section 1.4.3, Contrast ratio should be at least 4.5:1 for normal text and at least 3:1 for large-scale visual presentation. Section 1.4.4, Except for captions and images of text, text can be resized without assistive technology up to 200% without loss of content or functionality. Section 1.4.5, Convey information through text rather than images of text if the technologies being used can achieve the visual presentation. Ensure content can be presented without loss of information or functionality, and without horizontally and vertically scrolling. The contrast ratio should be 3:1 for user interface components and graphical objects in visual presentation. Ensure no loss of content or functionality occurs by changing style property E.G spacing. Where keyboard focus triggers additional content to become visible and then hidden, provide a mechanism to dismiss the additional content. Guideline 1.4 Distinguishable, Level AAA. Contrast ratio should be at least 7:1 for text and images of text and 4.5:1 for large text in visual presentation. Ensure audio contain very low or no background sounds. For the visual presentation of blocks of text, provide a mechanism for selecting styling and spacing of the text. Images of text should only be used for decoration or conveying essential information. Principle 2. User interface components and navigation must be operable. Examples of Principle 2. Functions triggered via mouse or gesture are also available via a keyboard. All users are given sufficient time to read and use content. Content does not induce seizures. Users are given mechanisms to skip repetitive content. Landmarks are provided to assist in screen reader navigation, e.g. meaningful page title, semantic headings, ARIA landmarks, meaningful headers and meaningful and unique link text. Multiple paths are provided to navigate website structure. Guidelines for this principle. Guideline 2.1, Keyboard accessible, make all functionality available from a keyboard. Guideline 2.2, Enough time, provide users enough time to read and use content. Guideline 2.3, Seizures, do not design content in a way that is known to cause seizures. Guideline 2.4, Navigable, provide ways to help users navigate, find content, and determine where they are. Guideline 2.5, Input modalities, make it easier for users to operate functionality through various inputs beyond the keyboard. Reference: https://www.w3.org/tr/WCAG21/number operable. Guideline 2.1 Keyboard accessible. Make all functionality available from a keyboard. All web pages require this. Not all users have a mouse to navigate through your page. With this in mind, you must always provide a proper marked up page so that keyboards may navigate your page with ease. How to implement? All form and application controls can be operated from a keyboard. For example, arrows keys can control sliders, or numbers can be entered to set parameters. Tab keys can be used to navigate between form fields and buttons. Keyboard commands can be used to activate and operate video players. Keyboard commands can be used to close and control windows. Level A criterias. Section 2.1.1 All functionality of the content is operable through a keyboard interface without requiring specific timings for individual keystrokes, except where the underlying function requires input that depends on the path of the user's movement and not just the endpoints. Section 2.1.2 Ensure focus can be moved to and away from a component of the page using a keyboard interface. If keyboard focus can be moved to a component of the page using a keyboard interface, then focus can be moved away from that component using only a keyboard interface, and, if it requires more than unmodified arrow or tab keys or other standard exit methods, the user is advised of the method for moving focus away. Provide a mechanism for on and off keyboard shortcuts implemented in content. Level AAA criterias. Ensure all functionality of the content is operable through a keyboard interface without requiring specific timings for individual keystrokes. References. Understanding Guideline 2.1. Guideline 2.2 Enough time. Provide users enough time to read and use the content. The basics of this guideline is to provide a static page to a user if required, where the user can control the information. If your web page doesn't have any moving, self-adjusting, time-sensitive, or live content, then it's a static page that already passes this guideline. How to implement? When appropriate, the user is warned of time limit expiration and permitted to extend time. Scrolling or blinking text can be paused. Users have the option to block an automatic update of content. Exceptions are allowed when changes in timing would interfere with an essential function. Level A criterias. Section 2.2.1 Content is timing adjustable. Ensure that users can complete tasks without unexpected changes in content or context that are a result of a time limit. Section 2.2.2 Pause, stop, and hide. For moving, blinking, scrolling, or auto-updating information, ensure there is a mechanism for the user to pause, stop, hide the movement or to control the frequency of the update. References. Understanding Guideline 2.2. Guideline 2.2 Enough time. Level AAA criterias. Ensure timing is not an essential part of the event or activity presented by the content, except for non-interactive audio/video. Ensure interruptions can be postponed or suppressed by the user, except interruptions involving an emergency. When an authenticated session expires, ensure the user can continue without loss of data. Ensure users are warned of the duration of any user inactivity that could cause data loss except data is preserved for more than 20 hours. Guideline 2.3 Seizures. Do not design content in a way that is known to cause seizures or physical reactions. How to implement? So follow rule of 3 flashes or below threshold. Web pages do not contain anything that flashes more than 3 times in any 1 second period, or the flash is below the general flash and red flash thresholds. More specifically, it is stated that flashing objects should be avoided or limited to 3 flashes per second. Exceptions are allowed for flashes below the general or red flash threshold. The premise of both the guideline and section are simple: do not have content that flashes more than 3 times in 1 second. If there is doubt about your content passing this guideline, you should just revise your content. Level A criterias. Web pages must not contain anything that flashes more than 3 times in any 1 second period. Flash must not be below the general flash thresholds. Level AAA criterias. Ensure web pages do not contain anything that flashes more than 3 times in any 1-second period. Ensure motion animation triggered by interaction can be disabled unless the animation is essential to the information being conveyed. References. Understanding Guideline 2.3. Understanding Success Criterion 2.3.1. Guideline 2.4 Navigable. Provide ways to help users navigate, find content, and determine where they are. Most accessible browsing programs have several ways of navigating through a page using the identification of special tags such as header tags and anchor tags. This guideline instructs you and your developers on how to use these tags properly to conform to WCAG standards. How to implement. HTML frames are given meaningful titles. Users are given mechanisms to skip repetitive content. Landmarks are provided to assist in screen reader navigation, e.g. meaningful page title, meaningful headers, and meaningful and unique hyperlink text. Multiple paths are provided to navigate through website content. Keyboard users are able to see a cursor or other indicator of position on the screen. Guideline 2.4 Navigable, Level A. Section 2.4.1. Ensure that a mechanism is available to bypass blocks of content that are repeated on multiple web pages. Section 2.4.2. Ensure that web pages have titles that describe the topic or purpose. Section 2.4.3. Ensure focusable components receive focus in an order that preserves meaning and operability. If a web page can be navigated sequentially and the navigation sequences affect meaning or operation, focusable components receive focus in an order that preserves meaning and operability. Section 2.4.4. The purpose of each link can be determined from the link text alone or from the link text together with its programmatically determined link context, except where the purpose of the link would be ambiguous to users in general. References. Understanding Guideline 2.4. Guideline 2.4 Navigable, Level AA. Section 2.4.5. Ensure that more than one way is available to locate a web page within a set of web pages except where the web page is the result of, or a step in, a process. Section 2.4.6. Ensure that headings and labels describe topic or purpose. The keyboard operable user interface should have a mode of operation where the keyboard focus indicator is visible. Section 2.4.7. Any keyboard operable user interface has a mode of operation where the keyboard focus indicator is visible. Guideline 2.4 Navigable, Level AAA. Ensure information about the user's location within a set of web pages is available. Provide a mechanism to allow the purpose of each link to be identified from the link text alone. Section headings should be used to organize the content. Guideline 2.5 Input Modalities, Level A. Make it easier for users to operate functionality through various inputs beyond the keyboard. Ensure all functionality that uses multipoint for operation can be operated with a single pointer. For functionality that can be operated using a single pointer, provide a mechanism to abort the function before or after completion. For user interface components with labels such as text, have the text of the label at the start of the name. Ensure user interface components can also operate functionality operated by device motion or user motion. Guideline 2.5 Input Modalities, Level AAA. Ensure the size of the target for pointer inputs is at least 44 by 44 CSS pixels except when in a sentence or block of text. Ensure web content does not restrict the use of input modalities available on a platform except where the restriction is essential. Principle 3. Information and the operation of user interface must be understandable. Examples of Principle 3. Site is free of unannounced pop-up windows. Separate submit or go buttons/links are provided to initiate page changes, versus auto-submit upon selection. Navigation and labels are consistent across a website or application. Mechanisms are available to detect errors and provide clear instructions to users on fixing errors. Language of text or subsection of text is identified. Guidelines for this principle focuses to have understandable user interface. Guideline 3.1, Readable, make text content readable and understandable. Guideline 3.2, Predictable, make web pages appear and operate in predictable ways. Guideline 3.3, Input assistance, help users avoid and correct mistakes. Reference: https://w3.org/tr/WCAG21/ number understandable. Guideline 3.1 Readable. Make text content readable and understandable. How to implement. Identify language of text or subsection of text with a language code. Identify and define unusual words or jargon. Level A criterias. Ensure the default human language of each web page can be programmatically determined using the HTML-lang attribute. Level AA criterias. Ensure the human language of each passage or phrase in the content can be programmatically determined except for technical terms and vernacular. Level AAA criterias. Provide a mechanism for identifying specific definitions of words used in an unusual way, including idioms and jargon. Provide a mechanism for identifying the expanded form or meaning of abbreviations. Provide supplemental content text when the text requires reading ability more advanced than the lower secondary education level. Provide a mechanism for identifying specific pronunciation of words whose meaning, in context, is ambiguous. Guideline 3.2 Predictable. Make web pages appear and operate in predictable ways. How to implement. Avoid unannounced pop-up windows. Avoid disabling the browser's back button. Provide a separate submit or go button / link to initiate page changes, versus auto-submit upon selection. Allow automatic slideshows, videos, and scrolling / blinking text to be paused. Give users the option to block automatic updates of content. Level A criterias. Ensure no user interface component initiate a change of context when it receives focus. Changes made to the settings of any user interface component must not cause a change of context unless the user has been warned before using the component. Level AA criterias. Ensure navigational mechanisms that are repeated on multiple web pages occur in the same relative order, unless a change is initiated by the user. Ensure components that have the same functionality within a set of web pages are identified consistently. Level AAA criterias. Ensure changes of context are initiated only by user request and can be turned off. Guideline 3.3 Input assistance. Help users avoid and correct mistakes. How to implement. Provide appropriate form field validation. Provide clear labels for form and application controls. Provide usable instructions for entering information into forms and applications, preferably before the form field. Provide clear and usable error messages identifying the location of error and information for correcting it. Level A criterias. Input error should be identified and described in the text to the user when automatically detected. Provide labels or instructions when content requires user input. Level AA criterias. If an input error is automatically detected and suggestions for correction are known, then it should be provided to the user. Provide a mechanism for confirming and correcting information before finalizing the submission for web pages that cause legal commitments or financial transactions. Level AAA criterias. Ensure context-sensitive help is available. For web pages that require the user to submit information, provide a mechanism for confirming and correcting information before finalizing the submission. Principle 4. Content must be robust enough that it can be interpreted reliably by a wide variety of user agents, including assistive technologies. This is so that the coding of your web pages can be interpreted by newer web browsers as the World Wide Web evolves into a more advanced platform. Guideline 4.1, Compatible. Maximize compatibility with current and future user agents, including assistive technologies. Section 4.1.1, in content implemented using markup languages, elements have complete start and end tags, elements are nested according to their specifications, elements do not contain duplicate attributes, and any IDs are unique, except where the specifications allow these features. Section 4.1.2, for all user interface components, including but not limited to, form elements, links, and components generated by scripts, the name and role can be programmatically determined, states, properties, and values that can be set by the user can be programmatically set, and notification of changes to these items is available to user agents, including assistive technologies. By following the rest of WCAG, you will have satisfied this requirement. References. Understanding Guideline 4.1. Understanding Success Criterion 4.1.2. https://www.w3.org/tr/WCAG21 number Guideline 4.1 Compatible. Maximize compatibility with current and future user agents, including assistive technologies. How to implement. Use validated markup/standard markup. Label the name and role of all user interface components. Identify the value for all data fields, including parameters for interface controls. Level A criterias. For content implemented using markup languages, ensure all elements are unique, except where the specifications allow it. For all user interface components such as form and elements links, a user should be able to programmatically determine the name and role, and also programmatically set the states and value. Level AA criterias. Ensure status messages can be programmatically determined through role or properties and presented to the user by assistive technologies without receiving focus. The new proposed WCAG 3.0 comes under Project Silver, which started in 2016. For this team, the first few years were spent researching WCAG 2.x to find out what problems people were having with WCAG 2.x so that those issues could be well addressed. Project Silver later gained its official name, the W3C Accessibility Guidelines 3.0. The words web content were removed from the name because WCAG 3.0 promised to be a more all-encompassing set of guidelines for digital content, including not just web pages, but apps, virtual reality, and other devices making their way onto the internet such as smartwatches, TVs, navigation systems, and home assistants. Some of the major changes proposed from WCAG 2.x were the following. Make it easier to learn and understand the guidelines. Allow different types of guidelines to support more disability needs. Provide more flexibility for the guidelines to keep up with new technologies. Have conformance to guidelines better reflect real-world accessibility, including making allowances for bugs and other low-impact issues. There seem to be just as many people in hopeful anticipation of WCAG 3.0, as there are those who are worried it may undo some of the progress made by WCAG 2.x. WCAG 3.0 is guaranteed to shake up the accessibility industry as much as, if not more than WCAG 2.0 did when it first came out. Many things got far more complicated than they had been in WCAG 1.0. The W3C is aiming to publish a candidate recommendation of WCAG 3.0 sometime in 2023 and the final publication of WCAG 3.0 is expected somewhere at the end of 2024. Engineering practices for accessibility compliance refers to a set of techniques and guidelines that software engineers can follow to ensure that their products and services are accessible to people with disabilities. Let's talk about handling of web elements. Handling of web element refers to the process of interacting with different types of web elements such as buttons, text fields, drop-downs, checkboxes, and radio buttons, etc. using various methods and techniques. Handling of web elements involves identifying the web elements on a page, interacting with them by clicking, selecting, typing, or submitting forms, and verifying that the expected actions and results are obtained. Types of web element. 1. Structure and semantics. 2. Links and navigation. 3. Images and visual design. 4. Multimedia, animations, and motion. 5. User input, forms, and dynamic content. First we will talk about structure and semantics. Structure refers to the organization and layout of the content on a web page. The structure defines how the different elements of the web page are arranged, such as the header, footer, navigation menu, and content sections. Semantics refers to the meaning and context of the content on a web page. Use semantic markup to mark emphasized or special text. Use text to convey information that is conveyed by variations of presentation of text. Separate information and structure from presentation. Do not use style to convey structure. Next point is links and navigation. Links are clickable elements on a web page that can direct users to another web page, a specific section of a web page, or another website altogether. Links can be in the form of text, images, or buttons, and are often styled differently to make them stand out from other content on the page. Links are an essential part of web design as they allow users to easily access related content and information. Navigation refers to the system of links and menus that helps users move around a website. Navigation typically includes a menu bar, sidebar, or other elements that provide links to different pages or sections of the website. Some important points related to link and navigation. Link keywords and phrases. Links should open in the same browser window. Link text in buttons, i.e. it should follow the same guidelines as plain text links. Navigation length. Your left navigation should be succinct, so aim for 8 items or less if possible. Navigation order, e.g. home link to your site's index page should be the last link in your left navigation. Navigation wording. Shorten your navigation link text that is controlled by the title field of each page. Users should be able to quickly scan your navigation and know which item to click. Next point is images and visual design. Images. It is important to ensure that all images on a website have appropriate alternative text, alt text, that describes the content or function of the image. Visual design. It is important to ensure that there is sufficient contrast between text and background colors to ensure that users with low vision can read the content. Here, some important points. Use descriptive file names for your images, such as redflower.jpg instead of img_1234.jpg. Make sure all graphics have descriptive captions written in plain language. Avoid using graphics when written content could communicate the same thing. Use icons as helpful visual cues to connect to concepts. Only use icons purposefully and not for decoration. To use text over images, add a solid background behind the text or a dark overlay to the image. Use images that can be scaled up or down without losing their quality. If you're including links to images, use descriptive link text that accurately describes the destination of the link. Let's move on. Next point: multimedia, animations, and motion. Multimedia. Multimedia refers to the use of multiple forms of media, such as text, images, audio, video, and interactive elements. Animations. Animation refers to the use of moving images or graphics to create the illusion of motion. Animation can be used to draw attention to specific elements on a web page, to provide visual feedback when users interact with the website, or to create more engaging and interactive experiences for users. Motion. Motion refers to the movement of elements on a web page, such as scrolling, sliding, or fading in and out. Some important points are: use the appropriate file formats for your multimedia content, such as JPEG or PNG for images, MP4 or WEBM for videos, and MP3 or OGG Vorbis for audio. Optimize the file size of your multimedia content to improve page load times. Use proper timing and pacing for animations and motion effects to avoid overwhelming users and ensure that the content is easy to follow. Let's move on. Last point. User input, forms, and dynamic content. User input refers to the ways in which users interact with a website, such as clicking buttons, typing text, or selecting options from a drop-down menu. Forms are a specific type of user input that allow users to enter data into a website, such as filling out a contact form or entering payment information. Dynamic content refers to content that changes or updates based on user input or other factors. Here's some points related to user input, forms, and dynamic content. Use clear labels and instructions. Use appropriate input types for different types of user input. Provide feedback to users after they submit a form or provide input. Use semantic markup to make your content more accessible to screen readers and other assistive technologies. Use autocomplete and validation features to make it easier for users to enter information and ensure that the input is valid. What is images? An image is a visual representation of an object, scene, or idea. Images can help to grab the user's attention, create a more memorable experience, and enhance the overall visual design of a website. Normal users can see the images and understand what it speaks. How about those who cannot see the images? Visitor who is blind or visually challenged. Search engines that cannot read the images. It must be provide alternative text descriptions for images that can be read by screen readers, or by providing alternative content for users who may not be able to view the image. How to provide text description to the images? There are two easy ways to provide the text description to the images. The alt way, imgsrc equals alt equals VVNT services height equals 300 width equals 250 / The aria way, imgsrc equals aria label equals VVNT services height equals 300 width equals 250 / What is link or hyperlink? A link or hyperlink is a clickable element on a website that allows users to navigate to a different page or location on the internet. Links can be text-based or image-based, and are usually displayed in a different color or underlined to distinguish them from normal text. Links and hyperlinks are important elements of web design and can greatly enhance the usability and accessibility of a website. The text provided between a and /a is the link text. Links must have a description that informs the user about the target and must be clear. Links that target to external websites or non-web pages or links that open in a new window need to be called out. If the link is associated with an image and the image has an alternate text, link description is not required. Use the title attribute within the link wisely. Do not repeat the link description again in the title text. Remember the following points. Every a have a href attribute specified. If not, the link cannot be navigated with the tab key of the keyboard. The href attribute have a valid value, like URL or any file in the same directory, like different page of the same website. A document or some identifier in the same page. Bad example. One of the tourist attractions in the Bay Area is the Golden Gate Bridge. A href equals continue reading /a. People all over the globe reach to San Francisco to start their Bay Area trip. A href equals continue reading /a. When the user pulls the links list with the above examples, screen reader shows continue reading twice, user will not have any clue about the target of them. Good example. One of the tourist attractions in the Bay Area is the Golden Gate Bridge. A href equals continue reading about Golden Gate Bridge /a. People all over the globe reach to San Francisco to start their Bay Area trip. A href equals continue reading about SFO Airport /a. Validation for links. Open the page on the browser. Run an automation tool such as X and check for violations. In most cases, all the defects thrown by X are failures. 4. After checking with X, navigate the page using NVDA. Tab to each link and check if the link description is clear or not. What is table? A table is a way of organizing data in rows and columns, often used to present information in a structured and easy-to-read format. Tables are commonly used in many different types of documents, including reports, spreadsheets, and web pages. So let's understand how many types of tables. Primarily there are two types of tables on web pages. Layout tables. Data tables. First is layout tables. Tables that are used for presenting the content on the page are called as layout tables. Second is data tables. Data tables are used on web pages to represent some tabular data. Data tables may be simple or complex. Let's move on simple and complex data table. Simple data table. A simple data table is a basic form of a table that presents data in rows and columns. It is commonly used to organize and display information in a structured and easy-to-read format. Simple data tables are often used in documents such as reports, spreadsheets, and web pages to present data in a clear and concise way. Simple data tables can be customized with various formatting options, including font size, border style, and cell color. They can also be sorted and filtered to help users find the information they need. Complex data table. A complex data table is a more advanced form of a table that presents a large amount of data with multiple variables or attributes in rows and columns. It is commonly used to organize and display complex information in a structured and easy-to-read format. Complex data tables often contain a large number of rows and columns, with multiple variables or attributes represented in each cell. Complex data tables are often used in data analysis and reporting, such as financial analysis, scientific research, and business intelligence. Remember the following points. Avoid using tables for layout. Tables must be used purely for representing some data. All the header cells, that is column and row, must be marked with TH element. The TD element must be used for the data cells. The caption element, though optional, can be used to add a heading to the table. Screen reader must be able to identify the start and end of the table. While navigating with the screen reader navigation commands, user should be able to identify the header and content relationship. Repeat the navigation both horizontally and vertically to check for row headers and column headers. Now, talk about validation of these tables. Validation for layout tables. Open the web page in Mozilla Firefox or Google Chrome. Evaluate the web page using Wave extension. Press Ctrl and Shift plus U or right-click/hit application key and press Enter on Wave option or. In Mozilla Firefox, navigate to Tools menu and activate Structure/Order under Wave. Check if any layout tables exist on the web page. Validation for data tables. Open the page on the browser when the screen reader is switched on. Use shortcut Command T to check for any tables on the page. If the data tables exist, navigate the data table using screen reader table navigation commands. Now, we will discuss about headings. So what is headings? A heading is a text element that is used to introduce and organize content in a document or web page. They allow the users to skip through the page and directly read the information they need. Here, some important points which we have to remember. Each web page should have at least one and not more than two level 1 headings. The heading structure must be hierarchical in order. The reverse hierarchy is a bad practice. i.e., the subheading of H2 can never be H1. Validation for headings. Check 1. Missing markup. Missing markup refers to the absence of essential markup elements in a web page that help to define the structure and content of the page. Navigate from top to bottom using a screen reader. Identify if any content on the page that looks and function like a heading but not announced as a heading. Further on validation for headings. Check 2. Incorrect markup. Incorrect markup refers to the use of markup elements in a web page that are not used in the correct way, or that do not accurately represent the content they are used to describe. Markup elements are used to indicate to web browsers and other software how the content on the web page is organized and what it represents. Repeat step 1 and step 2 from check 1, i.e. open the page in the browser and navigate top to bottom using NVDA. Check if any content is read as heading but is a normal text. Check 3, heading hierarchy. Heading hierarchy refers to the use of heading tags in a structured way to create a hierarchy of content on a web page. Navigate through all the headings on the page. Check if the headings are in hierarchical order. Also verify if more than one level of heading is skipped in the hierarchy. Now what is list? A list is a group of related items or pieces of information that are organized in a specific way. Type of list. There are 3 types of list. Unordered list. Ordered list. Definition list. Now let's understand each, one by one. Unordered list. An unordered list is a list of items that are not ordered in a specific way. 2. Ordered list. An ordered list is a list of items that are numbered or otherwise ordered in a specific way. 3. Definition list. Definition list is used when the content of the page contains terms that have to be described to the user. Remember the following points. Use the appropriate list type, OL, UL, or DL, to clearly indicate the purpose of the list. Use the li tag to mark each item in the list, and nest lists correctly. Write clear and concise list items that accurately describe the information. Validation for lists. 1. Check 1. Navigate to the page on the browser. Check if the page contains any content that looks like a list. Verify if the identified items are marked with appropriate list markup or not. Further on validation for lists. Check 2. Open the page on the browser. Verify if all the items that are marked as lists are really list items or not. Check 3. Open the page on the browser when screen reader is switched on. Navigate through the page specifically where the lists are marked. Verify if start of list and end of list are announced by the screen reader. At the beginning of the list, screen reader will announce number of items the list contain. Count if the list announced by screen reader and the items displayed are equal. Next, let's learn about language. The language of each page must be specified in the markup. This will allow user agents such as browsers to render the content in the specified language. Further, it allows the assistive technologies such as screen readers to interpret the language in which it has to speak out for the user. Setting the language of your site allows assistive technology to interact with your content correctly. Remember the following. Use the lang attribute to specify the language of the document. Use the appropriate ISO language code to represent the language. Validation of default language. Method 1. Using X. Open the page you want to test in the browser. Run the automation tool X. If the result screen does not show the error of 3.1.1, the success criteria is pass. Further on validation of default language. Method 2. Manual inspection. Open the page you want to test in the browser. Open the source code. Usually the command is Ctrl+U. In the HTML element, the lang attribute must be available with appropriate value. E.g. lang equals n in case of English and lang equals fr in case of French. If this is provided, the success criteria is pass, else not. Next, let's understand what is parsing. While developing a web page, it is possible to make mistakes. Similar to any programming language, the HTML markup also need to be validated to have a clean and semantic code. The interesting part is not all the markup defects need to be fixed to meet WCAG compliance, though it is good to fix all. The 4 defect types that need to be addressed as per WCAG 2.04.1.1 parsing are: A. Duplicate ID values. B. Duplicate attributes for elements. C. Improper opening and closing of elements. D. Nesting elements according to specifications. For validating this requirement, we can use the W3C new validation service. This is the simplest way of identifying all the 4 defects at once. Though it is a simple way, in certain situations this may also be complex. Validation of parsing. Navigate to the new W3C validation service https://validator.w3.org/news/new. Choose the preferred input method, i.e. URL, file upload or code input methods. Provide the input depending on the selection from step 2. Hit the Validate button. Once the validation results are populated, activate the parsing bookmarklet from the bookmarks. Note that the defects listed may also contain some other accessibility issues such as missing labels for form elements, missing alternate text for images, etc. Note, other automation tools like Axe can identify the presence of duplicate ID values. What is flashing content? Any flashing content on the computer screen for more than 3 times in 1 second can cause seizures. Seizures can be caused due to photosensitivity. The fundamental concepts to keep in mind to test this requirement are: 1 is the flashing happens more than 3 times in 1 second. The opposing changes in relative luminance either from dark to light or light to dark is considered as one flash. If these flashing is observed more than 3 times in 1 second, this is a violation. Red flash is more sensitive to seizures and authors need to be extra careful in using them. Note, warning for the user or a mechanism for stopping the flash cannot be considered as exceptions for this requirement. 2 is the flashing content large enough? Any flashing content that covers larger screen area than 341 x 256 pixel block on a standard 1024 x 768 pixel screen is a problem for the users. This covers a larger portion, i.e. 10 degrees area on the screen as the users of computer work from a closer distance. This area can also be a combined portion of different blocks within 10 degrees of viewable area. Exception. Sometimes flashing can be caused due to the display or the computer rendering the image. Content authors will not have control over these types of flash. Note, blinking usually do not happen more than 3 times in 1 second. If it happens, then it is considered as flashing. Validation for flashing content. Open the page on a browser. Check if the page contains any flashing content. If no flashing content is available, this success criteria is considered as not applicable. If flashing content is observed, check for: is the flashing happens more than 3 times in 1 second? Is the flashing content large enough? If any one of the requirements in check 4 is observed, this success criteria is considered as failed, else passed. Let's explore on focus order now. As while navigating the page with a keyboard, the sequence in which the elements receive focus must be logical. If the order is missed, user may miss important information or might be confused in certain cases. In some cases, when invoking a button opens a modal window or an overlay. If the focus is not shifted to the newly opened modal or the overlay. Screen reader users and users who depend on screen magnifiers miss to understand that the new window is displayed if the focus is not shifted to these sections. Remember the following. Avoid using tab index values that are greater than 1 to manage focus order, as they may supersede logical tab order. Align the focus order with the reading order as much as possible in order to maintain a logical and intuitive navigation of the content. So, how to validate focus order while tabbing? Open the page on the browser. Navigate to each element on the page using keyboard only. The navigation flow in which keyboard tab key travels should be logical and intuitive. If the navigation order is illogical, this success criteria is considered as a violation, else the success criteria is passed. Validation of focus order for modals and overlays. Open the page on a browser. Check for any elements that invoke modal windows or overlays. E.g., calendars on travel booking applications. Activate the element and see if the focus jumps to the newly opened window or overlay. If the keyboard focus does not move to the newly opened modal, it is an accessibility violation. Else not. Remember that on closing the modal or overlay, the focus has to trigger back to the initiating element, else it is an accessibility violation too. Let's understand about keyboard usage. People with motor difficulties will have tough time in using the content if the actions are mouse dependent. The motor difficulties can range anywhere between not having hands, to not having few or more fingers, to stress on muscles. Tremors in the hands can also cause difficulty in pointing the mouse onto a particular element on the screen. Providing keyboard access to all the functionalities of the page can solve this problem. The functionalities on the page include simple interactions such as activating a button, filling up a form, to more complex interactions such as sorting a column in a table, drag and drop. Taking care that all the functionalities of the page usable by keyboard alone is required as per WCAG standards. This will also benefit low vision and blind users. That's why keyboard access to a website is a must for the usability of your site. All interactions and information that can be accessed with a mouse must be accessible with just a keyboard. Remember the following. Use proper HTML tags for structuring the content, such as header, nav, main, and footer. Add keyboard focus to links and form controls using the top index attribute, so that they can be accessed using the keyboard. Use the ARIA label attribute to provide alternative text for elements that are not labeled explicitly. Validation for the use of keyboard. Open the page on a browser. Navigate to all the interactive elements using the tab key of the keyboard. Check if all the functionalities are navigable and actionable by keyboard alone. If a keyboard can access all the functions of the page, this success criteria is considered pass, else failed. Now let's see what is keyboard trap. Except for the scenarios where keyboard trap is necessary for the function of the page, it should be trapped within the sections of the page. E.g., keyboard trap is a required scenario for modal windows. In other situations such as an iframe or similar sections, keyboard shouldn't be trapped. If keyboard trap could not be avoided and a specific key command/access key is required to exit the trap, inform the behavior to the user before they encounters it. Also inform the commands or gestures assigned to move away from such section in advance. Validation for keyboard trap. Open the page on the browser. Navigate the entire page using Tab and Shift plus Tab key of the keyboard. Observe if the navigation of the page is affected due to a trap of keyboard in certain portions of the screen. If the keyboard navigation is trapped in any sections of the page, it is an accessibility violation. Else this success criteria is passed. Next is about page title. The title of the web page must be descriptive enough to explain the content or functionality. A screen reader user first reads the title of the page to confirm that they are on the page they are looking for. When you landed on the page from a social media applications or through search engines, everyone looks at the title to ensure that they are on the right page. User agents such as browsers display the title on the title bar. Screen readers read them with a simple key command, e.g. NVDA/NT with NVDA. Title is the one shown when the user switches between the tabs. Here are the things you need to remember. The title should accurately reflect the content of the page. Avoid using generic titles like Home or Page 1 that don't provide any useful information. Avoid using duplicate titles across multiple pages to avoid confusion and improve SEO. Validation for page title. Open the page on the browser. Look at the title bar and read the content. The title should describe the content available on the page. Validation with screen reader. Open the web page you want test when the screen reader is switched on. Press NVDA/NT and hear what it speaks. Check if the title spoken out by the screen reader explains the content of the page as well as the name of the website. Note 1. If the point C is satisfied, then this success criteria is passed. If not, it is failed. Note 2. Testing with any one of the validation method above is sufficient. What bypass blocks is? Every website will have repeated blocks of elements in most of the pages. It would be painful for a user who depend on a keyboard to reach the main content of the page bypassing all the repeated elements with the Tab key. They may have to press the Tab key many times before reaching to the main or required content. Screen reader users have to press tab as well as have to hear a lot of redundant information before reaching the main content. Low vision people have to search for the region where the main content begins with their magnifier. Hence, bypass blocks are mechanisms that skip over repeated material on a web page. They are important for users who navigate with a keyboard because as they will allow users to skip over repeated sections and go to the content they are looking for immediately. Remember the following. Ensure that your bypass blocks have descriptive and meaningful labels, so that users with screen readers can understand what the block is for. Make sure that the bypass blocks are located at the beginning of the page, before the main content, and that they are easy to find and use. Validation of bypass blocks. Open the page in the browser. At the beginning of the page, check for an option that keyboard-only user can use to jump directly to the primary content region, e.g. links such as skip to main content. Validation of bypass blocks. If available, activate it with space key or enter key and check if the focus moves to the primary region of the page. If this mechanism is not available, check for proper heading structure. If headings are not provided, check for landmarks. Having any one of these is sufficient to pass this success criteria, but having more than one of these is recommended as different users depend on different navigation mechanism. Validation with screen reader. Open the page on the browser when the screen reader is on. Tab to the web page from the top. Navigate to the top of the page using Ctrl and Home. You should hear a skip link such as skip to main content in first 3 tabs. Once you hear skip to link, press space or enter key to reach to the primary content section. Press NVDA and up arrow. You should hear either the main heading of the page or a similar content that represent the primary content section. NVDA and up arrow reads the content NVDA has current focus. If this is not available, check for heading structure on the page. Use heading shortcut H with NVDA on. Or press NVDA plus F7, function key 7, to pull the elements list dialog. Select the headings from the choices. The headings must be hierarchical in structure, allowing the users to jump to the desired section. Also check for the use of landmarks on the page. Use the shortcut D to move between different landmarks. Or use NVDA plus F7, function key 7, to open NVDA elements list dialog. Select the landmarks from the choices. Check for prominent landmarks such as banner, navigation, main, complementary and content info. Having skip link or proper heading structure or landmarks is sufficient to satisfy this technique. However, having more than one way of bypass technique help different user groups. Let's talk about name, role and value. A name or an accessible name is something read out by the screen reader when user focus on it. In the case of accessible name, the text read out by the screen reader is not necessarily visible on the screen. A role is a simple information shared out to the user to understand the type of element and its behavior. So, the name and role of each user interface element on the page should be programmatically available, so that assistive technologies can gather information about and interact with them. Things you need to remember. Use native HTML elements wherever possible. Make sure custom widgets are keyboard operable using spacebar or enter keys. Provide tab index equals 0 for custom widgets so that they receive tab focus. Read ARIA specifications to understand the implications and the consequences of ARIA roles, states, and properties before using them. Here, understand validation for names. Firstly, open the page on the browser when the screen reader is switched on. Navigate to all the controls on the page, e.g. links, form elements, and other custom components. When the user reaches to each element, screen reader must announce its accessible name, e.g. cancel button where cancel is the accessible name. If all the controls have accessible names, then this requirement of the success criteria is considered as passed, and the test engineer have to check other requirements of the success criteria described in the next sections. If any of the elements does not have accessible name, then this requirement of success criteria is considered as failed. Roles. So, Basically 6. While looking at a link, one will understand that it takes to a different page. A button submits some data to the server or does an action for the user. A radio button selects an option from a group, etc. These types of elements are called roles. A link is a role, a button is a role, etc. When accessed with the screen readers, each element except for a paragraph, line of text, all other elements should have a role announced. In case of custom controls, the tabs, menus also need to be informed to the user. Validation for roles. Open the page on a browser when the screen reader is switched on. Navigate all the elements on the screen and check if all the elements have a role read out by the screen reader. If all the elements are having a role assigned, check if these roles are appropriate to the function of the element. If the roles are available and are appropriate, then this requirement of the success criteria is considered as passed, and the test engineer have to check other requirement of the success criteria described in the next sections. If the role for one or more elements are not provided, this success criteria is considered as failed. Here we'll learn about color contrast. In the spectrum of people with visual challenges, considerable number of users will be people with low vision and those have color blindness. The persons with low vision may be of different experiences. Some might only have central vision, some may have blurred vision, some may be having difficulty in reading smaller font or that is far from them. Hence, color contrast is an important consideration in accessibility testing. It affects the ability of users with visual impairments to read and understand content. That's why here are some things to remember. Each web page should have 4.5:1 ratio between the foreground color and the background color. Color dependence is the need to see color to understand the information. Like that, the required fields are red. Color contrast ratio for links at least 3:1 with the surrounding or underline. Validation for color contrast. Open the page on the browser. Open the Color Contrast Analyzer, CCA, tool. For each color combination, pick the foreground color using the color palette and repeat the same for background color too. Once you pick the foreground and background colors, the tool should display the contrast value and also mentions if it is pass or failed. For the content that need to be checked with surrounding content, pick both the colors and the tool should say if it is passed or failed. If the color contrast analyzer say it is passed else failed. Now we will learn about landmarks. All elements on a page should be contained in a landmark element. This helps users of it quickly navigate a page. HTML5 provides built-in landmark elements such as main, nav, aside, header, footer. When using HTML5 elements, don't define role. Remember the following. Each web page should have landmarks that identify the different sections of a web page, such as the main content area, navigation, and footer. Using landmarks makes it easier for screen reader users to navigate a web page. When using landmark roles, it's important to make sure they are used appropriately and accurately reflect the content of the page. For example, the header role should only be used for the page header, not for other headers on the page. Landmarks can also be helpful for search engine optimization, SEO, as they provide additional information about the structure and content of a page. See how to do validation for landmarks. Check the HTML code. Ensure that the landmarks have been implemented using the correct HTML5 tags. Test with screen readers. Navigate the web page and verify that the landmarks like that. The screen reader should announce the header landmark as header and the NAV landmark as navigation. Here we will understand about forms labels. Accessibility of forms is an important and major concept in web accessibility. In one or the other ways, every website will have at least one form. While most other elements on the web page allows the user to read the content or understand the visual presence or will allow the user to move between the websites and web pages, forms allow the users to interact with other parties either by sharing the feedback, contacting the webmaster, storing their data on the website, etc. Remember the following. Each web page element must have form label associated with its instructions and errors. Every website will have at least one form, and every form element must have a label. Without label does not know what do I input here? Every form element on the page must contain a label. The form elements referred for this purpose are input text elements, text area elements, radio buttons, checkboxes, drop-downs. Let's understand it with an example. Bad example. Label 4 equals first underscore name 2 first slash label. Input type equals text ID equals first name 2. In this above example, first name label for and ID don't match. Good example. Label 4 equals first underscore name 2 first slash label. Input type equals text ID equals first underscore name 2. In this above example, first name label for an ID should be match. Then, how to check validation for form labels. Let's learn how to check it with X tool. Open the page in the browser. Run any automation tool such as X. Check if the tool finds any violations of missing labels. Or check with screen reader. Open the page on the browser when the screen reader is switched on. Navigate the form elements on the page using Tab key of the keyboard. When the keyboard reaches the form element, screen reader should announce the label along with the form element with its roles and other semantics. Now we'll talk about text resize. So, as we continue talking about the persons with low vision, some users like to increase the font size to read the text. Remember our grandparents wearing glasses to read the newspaper? This means all of us are going to be increasing the font size or zooming the browser in the future for better readability. And text can be resized without assistive technology up to 200% without loss of content or functionality. And increase the font size to read the text for that persons with low vision. WCAG requires the users to be able to increase the text size up to 200%, double the default font size. Let's understand about validation for text resize. Open the page on the browser. Press Ctrl++, plus sign, 6 times. Check if all the content is readable. Content should not be overlapping on adjacent content or moving away from the user viewable region. Verify all the functions of the page such as filling up a text field, activating a link or button, selecting a radio button or checkbox are usable. If steps 3 and 4 are passed, this functionality is passed, else failed. Developer due diligence for accessibility. It is the process of ensuring that digital products and services are accessible to people with disabilities. This process involves developers, designers, and other stakeholders taking proactive steps to identify and address potential accessibility barriers before a product or service is released to the public. By implementing developer due diligence for accessibility, developers can create digital products and services that are usable and inclusive for all users, regardless of their abilities. This not only benefits users with disabilities, but also improves the overall user experience and can increase the marketability and profitability of digital products and services. Below are the web page evaluation checklist. What content do you have on your web page? Forms or other interactive content? Animations, moving content, flashing content? A form that causes a legal/financial commitment, grades a test response, or modifies/deletes data. Audio content that plays automatically and lasts longer than 3 seconds. A time limit of any sort. A table containing data. A CAPTCHA, human verification, script. A visual presentation without audio such as a slideshow. A movie that has both audio and visual elements. Audio-only media, such as music, spoken phrases, etc. Phrases in the web page that are not in English. Continue by checking off every checkpoint that your web page satisfies. Once you've checked off all of your boxes, you have completed a WCAG evaluation for your web page. This represents checklist for evaluation of web content. This is the annex tour, Accessibility Developers Guide. Let's focus on Accessibility Developers Guide and its use by developers. So with this, we have come to the end of this video. We hope you guys find it informative and helpful. Thanks for watching. VVNT Accessibility Task Force supports #DEIA. VVNT promotes diversity, equity, inclusion, and accessibility accommodation, with its premium implementation support on universal design and accessibility practices.